In this lesson, we're going to look at percent basics. Now, you may be wondering what is the meaning of percent? Well, in order to work with percent, we will need to convert the percent either to decimals or fractions in order to use them in calculations. We cannot use the percent directly as a percent when doing in calculations. So we have to know first, how to convert a percent into either a decimal or a fraction, depending on the needs of our problem. So percent literally means per 100 or parts per 100. So when we talk about 40%, this is equivalent to the fraction 40 over 100. And if we take 40 and divide it over 100, we will get the decimal 0.440. Now notice that let's say we have a situation where we have 80 out of 200. Well, that is also a percent, because technically that would be 40%, since if we divide 80 by 2, we get 40, and if we divide 200 by 2, we get 100, and that would give us 40 over 100, which would imply 40%. We can also reduce this fraction further, if need be, because we can notice that 4 goes into 40 10 times, and 4 goes into 100 25 times. So now let's look at some questions and how we would do this. Well, in general, when we have a percent or some part of a whole, a percent is equal to the part of the whole. So usually when we want to calculate a percent, we look for the part, we look for the whole, and we multiply it by 100%. Or equivalently, if we want to find a part of something, that would be equal to the percent times the whole. But remember, we don't take the percent directly here. We must convert the percent. Just like here, if we just do the part of the whole, it won't give us the percent directly. We have to actually multiply it by 100% after we have the fraction or decimal. So let's look at a situation. Let's look at some questions to see if this will clarify things. This should clarify things a little bit more. So to do these calculations, we want to write the percent as a decimal. So we're going to write each of these as a percent. So first what we're going to do is we're going to look at this question 1A1, 1 or 1AI is 1/4. So how would we convert that into a percent? Well, let's go over to the whiteboard and we're going to work it out and see how we can do this. So let's look at question number 1. And we have 1/4 or 1/4. And we want to convert 1/4 into a percent. Well, you could take your calculator and divide 1 divided by 4, and we will get 0.25 if you put that into your calculator. And that, in order to convert it into percent, we must multiply that by 100%, and that will give us 25%. Now remember, you have to put the 100%. We can't just put the 0.25 because the percent is a percent. So coming back here to the PowerPoint, we're just going to fill in the answer that we found in the whiteboard. And here we have it. Right here, the 0.25, and we found that 1/4 is equal to 0.25 is equal to 25%. Now let's look at example II. So here we have, it's already 0.02, and here it's already, as we can see, in decimal form. So let's go back to the whiteboard and calculate this explicitly.
And the next question on the PowerPoint was 0.02. Well, just like above, we now already have it in terms of a decimal. So here we will just multiply it by 100%. And we end up getting that to be 2%.
Now coming back to the PowerPoint, we fill it in. And here it is, our 2%. And here, the next one, we have 3i. And again, we'll go back to the whiteboard, calculate it out explicitly.
And for the third one, let's see what we have. Wow, we have 2.35. Well, in certain circumstances, things can be more than 100%, and this will be explained later. But we still have to multiply this to put it in terms of its percent by 100%, and that will give us 235%.
Now coming back to the PowerPoint, we'll just fill it in, and there we have, just like we did on the whiteboard. Now let's look at question 1b. And question 1b asks us to convert 42% to a fraction and a decimal. So we will return to the whiteboard and work this out in detail.
So here on the whiteboard, we're going to convert 42% into a fraction and we're going to also convert it into a decimal. Now remember the definition of percent. Percent is the number over 100%. So we have 42% divided by 100%. So anytime you have something that's the same over the same, well, that cancels out. So we end up getting 42 over 100. Now we want to simplify this as much as we can. So we see we can divide both 42, we can divide that by 2, and we can divide 100 by 2. So if we divide 42 by 2, we get 21. And if we divide 100 by 2, we get 50. And that's the simplest we can make the fraction. Now, in order to put it as a decimal, well, the easiest way to do it is just divide it. So if we divide, or we could, there's one way we can do, we can just divide it on our calculator, and that will give us 0.42, or we can go to our original one here, 42% over 100%, and we realize that if we divide 42% over 100%, we also get 0.42.
Now, returning to our PowerPoint, I'll just fill in the information that we just figured out on the whiteboard, so it's a little easier to read. And here we found the fraction is 21 over 50. And just like on the whiteboard, we found the decimal is 0.42. Now question 1C asks us to convert 15% to a fraction and a decimal. And so now what we will do again is we'll return to the whiteboard, work it out in detail.
1C, and I'll mark C. And we're going to convert 15% into a fraction and a decimal. Well, as we said with the definition of percent, 15% divided by 100%, and then the percent signs cancel out, so we get 15 over 100, and we see that both 15 and 100 is divisible by 5. 5 goes into 15 3 times, and 5 goes into 100 20 times. And that's the simplest that we can reduce that particular percent as a fraction into. Now we want to also convert that into a decimal. And as I said, we can just straight out divide here. So you just 3 divided by 20. And I'll write that here to make it clear. 3 divided by 20 will give us 0.15. Or you can go straight to the percent here, and you can see that another way to look at the percent is to actually just move over decimal points. So one other way to do it is to have 15, drop the percent sign, take the decimal point, and you can move it 2 spaces, and this will also give you 0.15. Or you can just divide 15 over 100, and again, that will also give you 0.25. So however way you like to do it, that's fine. So there's more than one way to convert a percent into a decimal.
Now coming back to the PowerPoint, again, I'll just fill it in. So we found that 15% as a fraction is 3 over 20, and as a decimal is 0.15. In question 1D, we're asked to fill in this table. So let's look at the first line and see what we're given in the table. So here we are given a fraction, and we want to figure out from this fraction its decimal and then the percent. So let's go to the whiteboard and work this out in detail.
So we have 3 over 5. And we want to convert that into a decimal, which is probably the easiest thing to do. So what I'm going to do is I'm going to take 3 and I'm going to divide it by 5. And what do I get when I take 3 and divide it by 5? Well, I get 0.6. So we started out with the fraction, and I took the fraction and I converted it into a decimal. And now I'm going to take the decimal and convert it into a percent. Now, as I said, there's a number of different ways we can do that. We can take the decimal and multiply it by 100%, and that will give us 60%. Another way we can do that is to take the decimal, move the decimal point over 2 places, fill in, and add the percent sign, and this will also give us 60%. So however you like to do it is fine.
Coming back to the PowerPoint, we'll just fill in the table here as we saw in the whiteboard, and we found the decimal was 0.6, and we found that that was 60%. Now we'll go to the second line of our table, and we see we're given the decimal. So we want to then figure out the fraction and percent, so we'll go to the whiteboard and work this out.
So here we have our whiteboard, and we're given the decimal 0.02. Well, as we found out, there are 2 ways we can do this. We can do it as 0.02 times 100%, and that will give us 2%. Or we can take the decimal point, move it over 2 places, and add a percent sign, and that will also give us 2%. Now, the easiest thing to do is to take our percent in order to convert it into a fraction, is to take our percent, 2%, and divide it by 100%, based on our definition of percent. So the percent signs cancel out. We're left with 2 over 100. And then we want to reduce that. And we see we can reduce that because 2 goes into itself and 2 goes into 100. And that would be the same thing as 1 over 50.
Having worked it out on the whiteboard, we'll now fill in our table. So we found that our fraction was equal to 1 over 50, and we found that 0.02 was 2%. In the third line here, we see we're given a percent, and we want to figure out the decimal and the fraction. So again, we'll go to the whiteboard and work this out in detail.
Well, here we're given 72%. Well, probably the easiest thing to do would be to go back to our definition of percent and see if we can convert that into a fraction. So we have 72% divided by 100%, and of course those cancel out, and we see that 4 goes into 72 and 4 goes into 100. So 4 goes into 72 18 times, and 4 goes into 100 25 times. So that becomes our fraction. Now the last thing we want to do is we want to take that, and convert that into a decimal. Well, as I said, we can just divide 18 divided by 25, or realize that a percent is divided by 100. So we end up, after we do that, we end up with 0.72, is our decimal. Now remember, you don't put a percent sign after the decimal. A lot of times people make the mistake. When you mean a percent, you put a percent sign. If you do not mean a percent and you mean a decimal, you leave it as a decimal.
Coming back here to the PowerPoint, again, we'll fill in our table, and we found that 72% was 18 over 25, and it was 0.72 as a decimal. In the fourth line here, we have a decimal. Well, we have the decimal 0.5 and a 2, but that's okay because we can work this out just as a percent and a fraction. So we'll go to the whiteboard and work this out in detail.
So in this case, we're given our decimal is 2.5. Now, as before, there are two ways we can do this. We can take this 2.5 and multiply it by 100%, and we'll get 250%. Don't be afraid that you have 250%. This can happen. Or you can take the 2.5, move the decimal point 2 places over, and add the percent sign to also get to 50%. Now we want to put it in terms of a fraction. So if we put it in terms of a fraction, we can take our percent definition as we had before, 250% over 100%. And if we do that and we reduce that, we can get 25 over 10. Now notice how I did that because I canceled out the percent, but I also saw that I have a 0, the same 0 on the top and the bottom, so I was able to reduce it to 25 over 10, and then I can further reduce this to see that 5 goes both into 25 and 10, and I end up with 5 over 2. And if I'm going to now make this into a mixed fraction, a whole number plus a fraction, so that means 2 goes into 5 2 times, and there's a remainder of 1/2. So that means that 250% is the same thing as 2.5, which is the same thing as 2.5.
Coming back to the PowerPoint, we'll fill it in, and we found that the fraction was 2.5, where the half part is really the fraction part, and this is the whole number part. And then the percent is 250%. And finally, in the last line here, we have 4.5. And so here we want to work out 4.5 and put it in terms of a decimal and then in terms of percent. So again, we'll go to the whiteboard and work out the details.
So in this case, we're given 4.5. So, well, we can know this, that 1/2 is the same thing as 0.5, so we can just write our decimal as 4.5. And again, we do the percent the same way. We can take 4.5 times 100% and get 450%, or we can take the 4.5, move the decimal place over 2 spaces, and add the percent sign, and again, we get 450%. So now we're ready to fill in the final line of our table.
So filling in the final line of our table, we get, as we did on the whiteboard, we put 4.5 in the decimal column, and then we put 450% in the percent column. In question 2, we're told that 243 people out of 400 people state they like dogs. And this could be done with a poll or interviewed or however they found out this information. But we want to figure out what percent this is. So here we have 400 people, here we have 243 people. So why don't we go work this out on the whiteboard and figure out what this percent is.
This is a situation where we must look at percent as a part over a whole, and then multiply it by 100% in order to get the percent. So the first part here, the part over the whole, will be our fraction, and then we'll multiply it by 100% to get our percent. So let's look at the information we have. So we're going to, in this, we survey or interview, or however we get the information, 400 people. And we asked them whether or not they like dogs. And we found that 243 of them said that they liked dogs. So we ask ourselves, in this information, looking at this information, what is the total? Well, the total would be all the people that we surveyed or interviewed. So the total, or whole, would be 400 people. And the part are the ones who say they like dogs. So the part in this case, like dogs, would be the 240. Now we set up the fraction as the part over the whole. So we said that the part is 240 and the whole is all the people we interviewed or surveyed. And we get, and if we divide that fraction, we get 0.6075. But that's not our percent. We don't have the percent until we either multiply it by 100 or move the decimal point over 2 places and put on the percent sign. So we can move the decimal point over 2 places and put on the percent sign, or we can multiply times 100%, and we get also 60.75%. So again, either way you do it is fine. If you like to move over, this is a little bit quicker, moving over the decimal point, but it's a little bit clearer when you just multiply it by 100%.
So as we figured out on the whiteboard, we found that what this means is of the people who were polled or interviewed, 60.75 stated they liked dogs. And as I said on the whiteboard, You may have noticed that percent can be found in two different ways. This way by multiplying the decimal by a percent, and the other way by moving the decimal point and placing the percent sign to the right of it. In question 3, it states, to win the election as a president of the United States of America, a person must obtain 270 out of 538 possible votes from the electoral college. What percentage of the overall electoral votes is this? Round your answer to the nearest tenth of a percent. So, as in our other problems, we will go work out the details in the whiteboard and come back to the PowerPoint.
In question 3, again, we have a situation where we have a part over a whole. So here we have part over, and the part is the number of electorates, of a number of votes we need from the electoral college. Divided by the whole, which would mean all the possible votes that there are in the electoral college. So all possible, or number of all possible votes. So in this case, one would need, in order to win in the electoral college, 270 votes out of 538 possible votes from the electoral college. So we want to figure out, well, what percent is that? So we take this and we want to convert this fraction here, and we want to convert it into a decimal. So we take 270 divided by 538, and we find that when we divide that, we get 0.5018. And then what we want to do is we want to find the percent. That's just the decimal. We want to find the actual percent. So in order to do that, as we said earlier, we can move the decimal over 2 places and add a percent sign to get 50.18%, or we can take 0.5018 times 100%, and we get 50.18%. Now the question also asks us to round to the nearest tenth. So here's the tenth and here's the 100th place. So we see in the 100th place there's an 8. Now, in order to, we want to figure out, should that 1 remain a 1, or do we round it to a 2? Well, according to rounding rules, if the 1 next to it is 5 or over, then this one will go to 2. If it's under 5, it will remain a 1. Now, since it's an 8, this means if we round to the nearest tenth, it will be 50.2%. And similarly for here, percent, and that means we have rounded it to the nearest tenth.
So now coming back to the PowerPoint, I'll just fill it in so it's much clearer now. So here we have 270 over 538, just like we did on the whiteboard. We turned it into a decimal, and from the decimal we got a percent, and we found it was 50.2%. Or you can move the decimal point and put the percent sign to the right. In question number 4, we're told that the sales tax in a town is 9.4%. How much tax will you pay on a $140 purchase? Now, here we're only asked for the tax, not the final purchase. So we'll go to the whiteboard and work out the details of how we can find how much tax we have to add to our purchase.
So here we have a situation where our tax is equal to 9.4% of our purchase. So that would be of our purchase, since our purchase is $140, that we want to find 9.4% of $140. So the first thing we must do is take this percent and convert it into a decimal. Now recall that there are two ways to convert it into a decimal. One is by moving the decimal point to the left 2 places and getting rid of the percent. And the other one is simply taking the 9.4%, dividing it by 100%. And we find that when we do that, we get 0.094. Now, in order to figure out what the exact dollar amount our tax is, we want to take this decimal and we want to multiply it by the cost of our purchase. So we have 0.094, and our purchase was $140. And when we multiply this, and remember your dollar sign, we get $13.16. So the tax on our $140 purchase is $13.16.
Coming back to our PowerPoint, I'll just fill it in as I've done. And so here, just like we found on the whiteboard, we found that we would have to pay an extra $13.16 in tax. So this would be the amount we have to pay in tax, and then of course our purchase was $140. And we would add that tax to our purchase when we go shopping. In question number 5 says, in a recent poll, 28% of 750 individual polled indicated they would vote Democrat in the next election. How many of the individuals would vote a straight Democratic ticket? So we'll go to the whiteboard and work out the details.
In question number 5, we have 750 individuals that are polled, and we're told that 28% of them are going to vote Democrat. Now we want to know exactly how many people does 28% represent. Well, in order to do that, we do it in a very similar fashion as we did when we calculated the tax of our purchase. So what we want to do is we want to take our 28% and we want to convert that into a decimal. So however you like to convert it into a decimal, moving it over 2 places to the left and dropping the percent sign, or dividing it by 100%, you'll still get as your decimal 0.28. Now you want to take the 0.28 and you want to multiply it by the total number of people that you polled times 750 people. So when you multiply 0.28 times 750, you find that you get 250 people, 250, but remember they're 250 people, so it's very important that you write people. Otherwise, one has no idea what you're talking about. So it's 250 people said they would vote Democrat. And that would be the answer to this question. So remember, it's very important that when you're doing these types of problems to take your percent and convert it into a decimal, and then you take your whole and you multiply the decimal by whatever your whole is represented by.
As we found in the whiteboard, we found that what 28% of 750 means is that it means that of those 750 people, 210 will vote straight Democrat. In question number 6, a lender requires a minimum down payment of 12% of the value of the home. You have $22,020 in cash available to use as a down payment for the home. So you want to determine the maximum home value you can finance. So in this question, you want to figure out how much home you can buy, given that this is the amount of money, $22,020, you can put as a down payment. So again, we'll go to the whiteboard and work out the details of how we could figure this out.
In question number 6, we need to understand what all this terminology means. So, what is a down payment? What does it represent when we're buying a home? Well, the down payment is a part of the whole cost of the house. So when we put down a down payment, we are putting down a part of the cost of the home equals the down payment. In this case, in our problem, or in this case, the down payment will cover 12% of the home's costs. So what we want to find is we want to find the maximum cost of a home we can afford, given that we have $22,000, $22,020. So we want to find how much we can afford if we're going to buy a home. So we have, and we saw earlier that we had the situation where the part was equal to the percent times the whole. And in this case, the part is our down payment. Our percent, well, we convert that into a decimal. That's our 12% in a decimal form. And the whole is the house we can afford, or home we can afford. So in our case, we're given the part, and we're given the part, that's the $22,000, $22,020 that we have set aside for this purpose. The percent is the 12%, but we must convert that always into a decimal. And the home we can afford, we'll call that V for the value of the home. So we just do some algebra and divide by 0.12, and we find that the home that we can afford is $183,500. So 183,500 is the home we can afford, given what we have set aside as our down payment.
In question number 6, a lender requires a minimum down payment of 12% of the value of the home. You have $22,020 in cash available to use as a down payment for the home. So you want to determine the maximum home value you can finance. So in this question, you want to figure out how much home you can buy, given that this is the amount of money, $22,020, you can put as a down payment. So again, we'll go to the whiteboard and work out the details of how we could figure this out.
In question number 6, we need to understand what all this terminology means. So, what is a down payment? What does it represent when we're buying a home? Well, the down payment is a part of the whole cost of the house. So when we put down a down payment, we are putting down a part of the cost of the home. Equals the down payment. In this case, in our problem, or in this case, the down payment will cover 12% of the home's costs. So what we want to find is we want to find the maximum cost of a home we can afford, given that we have $22,000, $22,020. So we want to find how much we can afford if we're going to buy a home. So we have, and we saw earlier that we had the situation where the part was equal to the percent times the whole. And in this case, the part is our down payment. Our percent, well, we convert that into a decimal. That's our 12% in a decimal form. And the whole is the house we can afford, or home we can afford. So in our case, we're given the part, and we're given the part, that's the $22,000, $22,020 that we have set aside for this purpose. The percent is the 12%, but we must convert that always into a decimal. And the home we can afford, we'll call that V for the value of the home. So we just do some algebra and divide by 0.12, and we find that the home that we can afford is $183,000. $1,500. So 183,500 is the home we can afford, given what we have set aside as our down payment.
So now coming back to the PowerPoint, we find that, just like I did on the whiteboard, that the maximum value of a home that I could purchase with the money that I've set aside for a down payment is a $183,500 home, a condo or a house or whatever that we're going to buy. In question number 7, we're told one banana contains about 425 milligrams of potassium. That is about 13% of the recommended daily amount of potassium. We're asked how much potassium should be consumed daily. So again, let's go to the whiteboard and work this out in detail and see what we get.
In question number 7, it's very similar to what we did in the previous question, because here again we're given a part, meaning we're told that the banana is 325 milligrams of potassium, and K is the chemical symbol for potassium, and that would be 13% of the daily recommended amount of potassium that one needs. So what we want to do, as we did before, we're going to take the part, and that's our banana, And we're going to make that that's equal to our percent. And remember, our percent is going to be in decimal form. And we're going to find the total daily recommended amount of potassium, which I'll just call variable K. So the part that we have, we're given 425 milligrams of potassium. And remember, we're given 13%, but we always must convert that into a decimal. So the 13% as a decimal, however you want to calculate it, is 0.13. So that's 0.13 times K. And K is just our variable. And we just do a little bit of algebra. So we divide this by 0.13, and whatever we do to this side, we do to this side. And that cancels out. So that tells us that our daily recommended amount of potassium is 3,269 milligrams. Now, if we want to change milligrams to grams, it turns out that as a conversion, 1,000 milligrams is equal to 1 gram. So that means milligrams is the same thing as 3.269 grams. So that would mean how much potassium we should have per day, which is the daily recommended amount.
Coming back to the PowerPoint, I'll just fill it in. And we found that the daily recommended amount is 3,269 milligrams of potassium, and we converted it into grams, which is equivalent to 3.269 grams. Thank you for watching this video. I hope that you enjoyed it, and I hope that it helps you in your work. And take care. Bye.